So today, our session, integrating naturals into existing stores. We spent some time already on Monday talking about industry trends, corporate sustainability trends, and CO2 as a solution. Yesterday, we explored some alternatives, distributed systems, micro distributed systems. And today we're going to be talking specifically about natural technologies in existing stores, or what to do with existing stores. So I am joined by our wonderful presenters today, Jim McClendon, Director of Walmart Energy with Walmart, Dustin Lilya, Principal with DC Engineering, Mike Ellinger, Principal Program Manager, Engineering Compliance and Sustainability with Whole Foods Market, Richard Heath, Program Manager with SEER2, and Brad Person, President Project Manager with SEER2. So with that, I'm going to kick things over to Jim to start us off on Walmart.
Great, thank you, Danielle. Welcome everybody. Glad you could join. Hope the information today's helpful and look forward to some questions. So I wanted to kick off with just trying to frame up where Walmart is in this journey towards sustainable emissions. So I've got a few bullet points here of kind of outlining what our goals are. And so as you can see from the first bullet, in 2020, we set a publicly stated goal to achieve zero emissions, basically aligning with the 1.5 degree from the CBTI target. So scopes 1 and 2. So what that means, there's a little diagram, a little graphic there in the corner, gives you an idea of kind of what it breaks down. So clearly you can see electricity is the majority of the scope 1 and 2s. And so there is a work stream dedicated around electricity, which is a goal in and of itself of 100% renewable energy. The 3 scope 1 components of refrigerants, mobile fleets, and on-site fuels also have dedicated work streams around shifting the refrigerants over to ultra-low natural solutions, mobile fleet electrification, and then on-site fuels is also building electrification. The 3 scope 1 initiatives, 2 of the 3 are the areas I lead, on-site fuels and refrigerants, different groups leading mobile fleet electrification. The goal of zero emissions has some step functions to it, 35%, 25% and 65% by 2030. Those help be more disciplined about achieving that objective by setting interim targets and interim goals. And so we can be measured externally and measure ourselves internally. And then the last bullet is just kind of a quick update from 2015 to last year, 2021. We're about 23% towards that 35% goal of 2025. So heading in the right direction, but clearly a little ways to go. Big chunk of that is around electricity and renewable contributions, as well as some of the mobile fleet and progress we're making. So if we go to the next slide, I think there's a couple of points I want to make here, and then we'll get into a project-specific example that Dustin's going to lead us through. But at the front end of this thing, I established these, what I call 3 guiding principles. They're just super simple, high level, but they've tried to kind of establish a true north for us. And that is, how do we shift this fleet over, roughly 5,000 stores? How do you shift that over by minimizing store disruption? Try to create a future ready state as you do that. And then, of course, to support the business, the lowest total cost of ownership. And as we look at these paths that Dustin's going to go through, we kind of evaluate those and look at how they support the 3 guiding principles: the store disruption, future state, and so forth. So those paths, you can read them there. I think Dustin's going to go into them a little bit more detail, but they're currently, I think everyone's familiar with and has seen before. How do you shift those into a fleet? How do you do that into existing footprint, which is the challenge? So if we go to the next slide, I think we're going to shift over now, and Dustin's going to talk about a project-specific example of how we try to do this and following those 3 guiding principles. Dustin?
Yeah, great. Thanks, Jim. Yeah, as Jim mentioned, for these transitional paths, this is the example project that we did in Chino, California. This was installing a secondary glycol system to an existing store. The intention of this project was really, as Jim pointed out, to demonstrate a bolt-on approach where minimizing store operations is a pretty key thing. And so the overall scope on this project was replacing medium temperature cases with secondary glycol system. This store had end of life scope of work where some of the cases, the medium temperature cases, were old and needing to be replaced. And so the goal was to do that in a way of adding in natural refrigerants. And so to do that, this project, we put in a conversion of reusing the existing high side system. It was originally a 404A store, and we converted that to an R448A refrigerant to minimize the GWP of the refrigerant that was going to remain in the store. But really, with putting in the medium temp glycol cases, that eliminated all of the store level piping that had HFC in it. And so it made a nice case study of getting a partial conversion to a low GWP or natural refrigerant, but it leads a pathway for eliminating the HFC completely on the next subsequent projects at the store, because we've eliminated all of the HFC refrigerant on those systems inside the store. So Danny, if you can go to the next slide. A little bit of a typo here. There were basically 2 systems that were converted here. So the first one here, it says eliminated 3,000 linear feet of HFC piping, was for the first rack, so the medium temperature D rack, and then the second one was the medium temperature E rack. So the picture on the top right is essentially the refrigeration rack house or weather pack that's on the roof. And the existing system here had individually circuited piping going out to all of the different cases in the store. And so what we put in was a standalone secondary glycol chiller. That picture on the bottom left actually is the pump skid, and it has integrated controls with it. So basically that pump skid is in a way a bolt-on approach where the existing refrigeration rack really just sees that chiller as a load on the system. And so we had to do very minimal upgrades or changes on the compressor rack to be able to use it. Each of the 2 systems basically stand alone from a control standpoint, and that was done intentionally to try to minimize, interruption to the store, so that the new system could be put in place while the existing system was running, and therefore, kind of decoupling the 2 as a way to mitigate, operational concerns from the existing system. But as you can see, a lot of the piping inside the store was replaced. We eliminated about a 85% total GHGP reduction on the store because of the refrigerant conversion, as well as eliminating all of the refrigerant going to the cases. And so there was a little bit of a discrepancy there that was targeted to be an overall 90% reduction, but the 85% was based on the way in and way out of the refrigerants. And there's some optimization of how much charge needs to go back into this system that we're still working through to try to get it over to that 90% target. Anyway, if you go to the next slide, Danny. What we learned through this project as sort of a demonstration of how to do this bolt-on system, that the keys to successfully integrating this really came down to a lot of extra coordination with store operations, the Walmart service team, engineering teams and then the OEMs actually creating this equipment. We spent a lot of time specifically having, weekly meetings discussing scope overall. How are we going to install the system, start up and commission the system, and make sure that as it goes in, it's seamless in terms of a typical business as usual remodel for Walmart, so that because of the natural integration, it didn't create any additional challenges to what the store operations team would see. And along with that, we did a lot of risk mitigation planning with some backup ideas, or we had a load testing chiller that we put in that could load test the glycol pump skid prior to conversion of all the cases, just to ensure that with the new technology that it would work well and be able to support the loads before we changed out all of the display cases. So that some of those things are really the key as to how to integrate these natural solutions without interrupting the store operation. So if we go to the next slide, Danny, again, some lessons learned here. Whenever you're putting in, new systems, we found that from a design and engineering standpoint, providing specific call outs for part numbers of items is very important. A lot of times, business as usual remodels in our industry, a lot of times things are in a spec, hidden in a spec, as to maybe allowing multiple options for valves or other components in the system. In this instance, we were very specific and provided, a list of the exact valves, the exact system components that we needed, made it a little easier from a procurement and coordination of the construction. The other key takeaway was, including manufacturers in the design review meetings during development. So as these systems are fine-tuned for the specific site, having the OEM and having the manufacturer develop some of those components along the way, it's really important to include them in the discussion and make sure that they're understanding and seeing the big picture of how the system's intended to operate at the store. As I mentioned, we also put in an artificial load bank on the chiller so that we could start it up and commission and test it prior to connecting live loads on the store. And that's not something that you would necessarily need to do on every project going forward, but for the first several, Walmart wanted to ensure that the system started up successfully, and that was huge on this project. We were able to fine tune the operation and ensure that chiller was going to perform, and had a lot more confidence that as we went into changing out the display cases, that any of the initial bugs had been worked out with the system. And that really enabled a pretty clean startup. Once all of the cases got in place, the system did start up successfully and has been maintaining good product temperatures along the way. So that was a key, is how do you plan for initial load testing or on-site evaluation of the systems prior to conversions. And then lastly, as part of the risk mitigation planning, including inventory of spare parts, or making sure that the service team, contractor, so forth, that this facility has availability of all of the parts is very important. We did have several, like a transducer failure, some other small items, and having those parts on hand really enables it to start up and not have challenges, and not have the technology get blamed. As you're converting this, it's very important to have a successful startup, so that you don't get a black eye on the technology out of the gate because you didn't plan to have ability to service anything that may go wrong. So that's essentially it. I don't know, Jim, was there anything else that you'd like to add into the lessons learned? Or
No, I think you hit the key points. For us, making sure we had good collaboration across the teams was critical. and all to come back and support that first principle I talked about, which is minimize store disruption. As most folks know, if you start interrupting trade within the stores, the best technologies in the world and the best tech applications will get a black eye, and then damage control just makes it that much harder to overcome, and we have to move forward. So appreciate all the work teams in making a successful project.
Great.
Great, thank you.
Thank you.
Thought the sunshade on the roof was a really good idea too.
That was the lifesaver.
I mean, yeah, it's 100 degrees in Chino and sunny. A pop-up tent does wonders, right?
Yeah. Great. Well, if you do have questions, feel free to pop them in the Q&A. We'll get to them at the end here. And next, we'll turn our attention to an example from Whole Foods Market, or several actually project examples. And I'll hand things over to Mike here to start us off.
Morning, everyone. So Whole Foods currently operates about 434 stores. That doesn't include offices or distribution centers. That's just our stores out there. As most people probably know, Amazon is our parent company. So we roll up under their climate pledge. So their goals are our goals at the end of the day. The climate pledge is our commitment to reach net zero carbon emissions by 2040, which in 10 years ahead of the Paris Climate Agreement. Refrigerants obviously play a huge part of that, and we take multi-tiered approach to addressing them. So we actively retrofit high GWP refrigerants. So we're through R22 a long time ago, right? So now we're focused on the 404s of the world. 507s of the world, anything high GWP. Many of those go to lower HFO blends. We install leak detections in all of our facilities, try to stay ahead of leaking systems, and keep our leak rates as low as possible. And then, as part of our retrofits as well, we have a end of life replacement system. So based on age, based on several factors, we look at where do we replace our systems and how does it make sense. Many of those systems do go to some sort of natural refrigerant. So next slide there, Danny, will talk about those. So we wanted to talk about a few projects we went through on our journey to natural refrigerants in existing facilities. For anybody that knows us, or at least our internal folks, we talk about Whole Foods as being a snowflake, right? So we do not build cookie cutter stores. Everything out there in our world, you can walk in, no store is the same. You'll see that as part of our presentation here, but 4 examples we wanted to talk about today. So we had 2 stores in San Francisco. The first one was a 407 facility, about 1,500 pounds. The second one had both 507 and 407 in it. Another one in Petaluma, California, where we had about 2,200 pounds of 404. And then the last one in Sebastopol, where we had both 404 and 407. We went to different technologies in these stores, transcritical, cascade CO2, micro distributed, and then some traditional DX racks as part of those. We did work through and with CARB on these are FRIP CARB projects to get incentives. Our partners at SEER2 helped us with all these projects here, and Richard's going to help us walk through some of the details on each project. So I'll turn it over to Richard here. We got to get Richard off from mute.
Did we lose Richard?
Oh, he's gone now. It wouldn't be a presentation without technical difficulties.
Danny, you're on mute as well. Usama, is it possible to unmute
There we
Richard's audio?
go. You know, I think Richard's might be working on it because I see he put his video off. So maybe just while we're waiting for a few minutes here for him to get his act together. Mike, if you can speak a little bit more about the carb FRIP incentives and you know, the role that the incentives played in this project.
Yeah, so they obviously helped offset the cost of these projects, which we will say are fairly substantial at the end of the day. NASRC helped us navigate that process, and I will say without the NASRC, we probably wouldn't have made it through it. We run very lean on the whole food side. I don't have a giant team of people that can help me work through those type of processes. So, you know, Danny and Morgan, I can't say enough good things about to get us through that process, and it's very much appreciated. So I can see Richard there back on video. So maybe
Just
Can
on
you guys hear
time.
me now?
Yes.
I apologize, guys. Apparently I can't be on video and audio at the same time for some reason. I do apologize. Let me just get my framework back to. All right. So where I was going with this is a lot of these discussions are around how we fit the transition to natural refrigerants into a broader corporate ESG strategy and sustainability. Jim had talked about, you know, where Walmart is going. Mike just talked a little bit about what the corporate goals are. You know, it's being pushed for a long time. We looked at refrigeration kind of, you know, on its own, and we did a lot of things to incorporate what we needed to for sustainability in this. I would say that, you know, as we go through this, step one in sustainability is that we remain profitable. You know, a lot of these systems and things that we bring in, if we have to make sure these things are that we can actually put them in and we remain competitive and profitable in our stores. So a lot of the decision making along the way is looking at how we incorporate these things and when we incorporate these and how it fits into a budget. When you know, earlier Tristan Coffin had a discussion on ESG, and he kind of ended with saying that refrigeration is the Cinderella of sustainability, and I think that's a great analogy. I mean, we're now being invited, you know, to the ball, and there's a lot of opportunity for us to you know, to make a big push to improve sustainability for supermarkets. And if there's another analogy to the ball, remodels would be it. The remodel is the ball that we're being invited to, and that's where the opportunity is for us to. There's more stores out there that are going to be remodeled and changed than new stores that are coming online in most instances. And the thing I'd say, going back to the Cinderella, in order for Cinderella to get ready for that ball, it took a host of help. That it had to have expertise and all the different things to get her ready for the ball. Exactly the same with doing remodels. It takes a host of people to figure out how to take the new technologies and bring them and get them integrated into a remodel process. And oftentimes that remodel, you're dictated by that first step of sustainability. That is budgets and being profitable. Oftentimes we don't have the luxury of replacing everything in the store and going to a new technology. So a lot of these are transitional steps. So what I'm going to go through here is in these 4 sites that we had, there's an opportunity for us to look at different technologies and figure out how to implement those as we go along and try to make that to where it could be repeatable. Understanding that these were, you know, the funding for these were supplemented, so it gave us opportunity to try some different things. The first site. This project was an existing direct expansion refrigeration system that served a 15,000 square foot sales floor. The system served both medium temp and low temp with 1,495 pounds of R407A with an evaporative condenser cooler. We came in and replaced that with a cascaded system with R44A over CO2. If you look at the drawings here, the photograph and the system, one of the things I'd like to point out is there have been sessions to talk about the technologies and the need for technical competency and the ability to operate these things. This system has a microthermal control system, and this screenshot that you're seeing has the entire system shown on there, each component of that system. And it gives the technician the ability to zoom in and to check things, and it's pretty quick. You can either see if it's red or green. It gets the technician hopefully to being at a point of being able to get right to the problem areas and operate these. Again, so this was a system where the medium temp cases were not being replaced. So the option here was not just to come in and wipe everything out and go to 100% natural refrigerant. Since the medium temp cases were not in the budget to be replaced, this is set up to where we were able to use a traditional refrigerant system with a DX system off the 44A rack. I think we're going to see that common across a lot of remodels. It's going to depend on what the scope is for the actual cases. Next slide, please. The site number 2, again, this was a store where the medium temp cases were not being replaced either. So in this particular system, what we did was we came in again with a cascade system, 44A over, we did a transcritical CO2 system at this store. So the transcritical CO2 picked up all of the low temp. At the same time, since I said the cases weren't being replaced for merchandising purposes, we still went ahead and picked up all of the medium temp evaporators in the walk-in cooler. So this got us in a position where, again, the store is now all the cases that were being replaced, we were able to get them over to a natural refrigerant and also pick up the coolers. The medium temp stayed on a 44A. We put in a new 44A rack that picked up those the existing medium temp cases and also the air conditioning in the store. Next one. So site 3, so all the cases were being replaced here. So this was replacing an existing direct expansion system that had 5 protocol units in there. So we came in on this system and replaced it with a CO2 cascade system. And this is a typical CO2 cascade where we were able to go completely to a transition to a 100% natural refrigerant. Next slide. And then the last system, this was again a site where we had the opportunity to replace all the cases, and this system had it had an existing direct expansion rack that used 200 pounds of R404A and 230 pounds of 407A. With this system, we used a micro distributed system that has in each case, it has the refrigeration system built in. So there's a chiller built in to remove the heat from those individual units. These were Hussmann cases with the cassettes on top of the cases and the walk-ins. So the chiller, it was a zero zone chiller that produced chilled water that provided water to the to each one of those units out there, and that lower chilled water temperature increases the efficiency of the distributed systems out there. It ended up being the total charge in the system was less than 3 pounds of R290 and had approximately 600 pounds of 44A on the chiller. So to transition to these things, it looks pretty easy on here. It's easy to look through paper and show the designs, but incorporating the steps to the remodel, I think the next steps we're going to go through, and Brad and Mike will walk through some of the obstacles and the things we had to overcome to get these systems in place.
Thanks, Richard. I don't know if you guys can hear me or it's coming up.
Yep, we can hear you and we can see your friend in the background.
Now, this is Jason. Jason was one of the project managers for the site 1 and 2. So I have him here for mainly supporting question and answers for any of the day-to-day technical that went on. So he looks much better now. He had hair when he started, by the way, on these projects. So there's a lot of challenges. And when you look at these 4 sites, when Whole Foods came to us with their goals and initiatives to transition to naturals and to test the implementations, we looked at different sites here that had downtown San Francisco applications versus a Northern California small town Sebastopol with a very small store format. So a lot of variations in the all these buildings that led us to what would work well for that location. So when you start putting it together with these goals, you have to look at what fits right, what gets you to the best results, and what has the best cost of ownership and serviceability, performance, and all the other goals in the corporation. So you've got a lot to think about in the planning process. But as we went through the integration on these, one of the things that came up that's in design phase, there's a lot of push with the Title 24 and the heat recovery initiatives that need to be utilized. So there's challenges in how do I do that? How is the best way to reclaim air, reclaim water? A lot of times you're dealing with locations of equipment, substantial distance away from air handlers or rooftop units and things. So how do you mitigate the piping distances? And you can see in the bottom left picture, there's a coil that we actually, in the receiving area, hung for use of air reclaim to get in compliance with 24, also to minimize the distance at which we were trying to pipe that gas over there to it for the heat recovery. The permitting process in these locations, and I'll go into more of the noise later, but is very difficult with all the fire departments, all the leak detection systems that you need to upgrade to the latest code compliances. And there's a lot of pressure in the design the planning phase really drives a lot of what your success will be on the installation. And when you're thinking about each one of these sites, there's different variables that you have to come in. And there's an industry problem right now with the cylinder shortage of CO2, and that all the availability of those, because they say the supermarkets are hoarding because we need to have a charge on hand for the store at all times. And where do you put those? And you can see we probably have 2 charges here because they've led to the shortage of cylinders, so they didn't get the old ones back. They got the store cold, but they didn't get the cylinders back. So, and in the top picture, you'll see that's a rooftop over an adjacent building next to the store, which is a multi-story with parking garage and residential tenants as well. We utilized this spot because that was the existing location, and it had an expansive framework that had been built over that roof line as a halo. And we looked at it to how do we incorporate that same location, because it has natural sound mitigation with the wall being right behind it, as you can see, and where the camera person is standing is an auto garage. So we had to actually modify that framework, analyze the loads through the phases of the project to make sure that we weren't overstressing any part or area, as we removed the standard DX system with a closed loop water pre-cooled tower at the facility and pump station. So a lot of that structural evaluation we've learned is big in the challenges that face us, is just how to get that same, a spot or a new spot or something that works and build off that framework or existing structure, or how do you reinforce the bar joist below to get you the right equipment in the right location that doesn't take, building the whole second store over it. And, I put down there, I got a slide of a fitting that gave us a little issue in the Petaluma store overnight. It's operating at, this is completely different materials that we've got to use, and it's operating at significantly higher pressure. And when you plan for these, you've got to be able to mitigate the fact that you're going to have a few more of these items that fail, or you're going to have the power outage that burps the system or vents the reliefs when pressures get too high, and you're going to have to come get them recharged. So, and I guess the one I skipped in the middle here was the space constraints, and the bottom middle photo, for lack of a better description, is kind of a hallway that we're getting, existing conduits and exhaust fans and ductwork and things like that through, with refrigeration lines squeaked over the top. Those are very, very tight quarters that we've got to try to get things in these buildings. And, especially when you're integrating with old buildings, there's, it's one thing when the store was under construction to get that, every aspect. You did that in a phase, where here you don't have that luxury. So you're constrained by, how do I get there, and how do I get my utilities with proper installation practices? Next slide, Danny. So this one, we're going to start with the picture all the way to the right. So in this design for this location, which was the transcritical CO2, we had an approach here because they had a closed loop water system existing that ran the refrigeration. And as we were looking at using that structure, we had to play some musical chairs, I call it. But we didn't have a way to get the new transcritical rack operating and enough space for its corresponding adiabatic gas cooler. So Hill Phoenix put together a skid for us with the heat exchangers, and we actually used the existing loop to pipe the water to those heat exchangers and use the heat exchangers as the gas cooler interim until we can get the supports available for the framework. Well, that was a great plan, but there was a point in time where the water tower had to come out. And I don't know if we got that far in the process in the design, how for, to have no interruption and still keep the schedule. We couldn't shut down. So we had to come up with a way to get it off that closed loop system and remove that so we could place the actual BAC adiabatic, but it couldn't be done in one night in this place, plus some noise restrictions. So we actually rented a meter from a fire hydrant, the fire department there, and utilized the fire hydrant water flow for the heat exchangers for about 2 days while we got the equipment removed and installed and in curfew. And we had some creative ladder supports that had to run the multi-story building for the fire hoses. And so it was quite a process, but I mean, these space constraints, how to get equipment in there are problems, and how to keep the store open. And then the last picture, you don't ever plan that you've got to run your hose by a sleeping person there on the sidewalk. So there's all kinds of obstacles you got to think about. Next slide. So with one of the downtown locations that we picked, the use of the heat reclaim and to the air situation, we had to pipe it into a Munters, which was going to be located on the roof. And if you look at the far pictures on the right, you'll see that down in a small space between the buildings is the location where the mechanical racks were. So 3 stories up is this rooftop where these other pictures are taken to the left side of those 2. So we've got a substantial difference in height, and then we've got to get a place for our adiabatic condenser. And you can see on the bottom left picture, we were able to utilize the discharge and return piping and do our diversion right there to the Munter system, which is on the right, the next picture over, for the air reclaim. And also the water reclaim was 1 story below the rack location. So we're effectively using the discharge gas of the 448 system to meet the heat recovery needs, but we're looking at it through integrating it into a very different locations because of where they're at. So some creative planning there. With this, when you're working in these locations, you have to employ a sound engineer. And what the sound engineer does is gives us a pre-reading or a target of what the building environment is. And then we also look at every piece of equipment they review and try to integrate that into something that meets the appropriate decibel levels at the property lines. And with that, you've got things that you need to incorporate. In this location, we had some extensive screen walls and sound walls that needed to be installed for some very agitated neighbors in the condos above the lower 2 pictures there. So Mike, I don't know if you want to join in on some of these these pains that we got put through, or
Yeah, so I think, when we talk noise ordinance, we talk several things, right? Obviously, the one Brad's mentioned here, which, you just have to be ahead of those and take them into account. You're looking at $1 million worth of sound walls right there, right? So it's something you have to be ahead of and make sure is in your budget as you work through the process. I mean, and the other part with noise ordinances is just local restrictions depending on where you're at, right? We can't shut down stores. We don't shut down stores to do these projects. So we typically have to work at night in order to make this happen. There's some jurisdictions you can't work at night, or there's a maximum sound ordinance you can have. We've had police show up on site before, try to arrest our guys and take them away because we're making too much noise. Restrictions on how you set cranes, how you have road closures, all those come into play to keep a store operating around noise ordinances, right? So we probably can't stress enough, at least in this area that we did these work in here in California, noise ordinances severely restricted how we had to work, and drove costs up on the project substantially based on the hours we had to work. I'll swap back to space constraints real quick too. Same thing, right? Anybody that has stores and multi-use buildings or in a city, there's no free space anywhere, right? Back to that picture Brad showed with the piping. That was great when the store was new and there was no people working in the store or trying to sell groceries. It's almost impossible to get through those in the time frame we have in the middle of the night to have a store operational the next day. So all those things come into play in our lessons learned there. So I think this slide is mine, but yeah, I mentioned it earlier. So we did have all these projects were FRIP projects, right? Their process is extensive to get us through. The NASRC has mastered that process. Without them, I will say I wouldn't have went through the FRIP process. We couldn't have done it on our own. So work with them for resources and support and additional funding to get through your projects in California. Some of the things we've already talked about, planning is key, right? Know what you're looking for up front, know what the restrictions are, know sound ordinances and restrictions on when you can and can't work. Consider capacities from your utilities. We ran into a couple of these stores where we wanted to do more, but we couldn't. We didn't have the electrical service in the store and we couldn't get through the process that it takes to upgrade a utility service in the store. So we weren't going to shut a store down for utility, right? So make sure you're addressing those up front. Especially again, in these areas, you have to have a place to stage your equipment, right? We were staging it offsite in warehouses, is bring it to the site just in time so we could set it that night. We just don't have the space in our facilities to store equipment and or interrupt operations. So staging of equipment and storage of equipment is key. Contractor training, especially depending on the area of the country you're in. Some folks have CO2 experience, some people don't have CO2 experience. There's great training programs out there through many of the OEMs. Make sure you're planning up front with them to ensure the contractor that you're working with has the capability and it has experience with it. Many of the folks have been through these at some point in time in their life, but they haven't seen a CO2 system in 2 years. So they need to make sure they're refreshed on where they're at. Project administration, commissioning experts, leading development integration. We lean on our partners heavily in the world of Whole Foods. Sear helped me with these projects. There's no way we could have done these projects without them. We have to use our external resources to work through these projects. They are, in my opinion, the most complicated projects we do out there, right? We talk about on number 7, keep it simple. It's extremely hard to do in these instances. We have a kickoff call for our stores, I explain to them, hey, we're replacing the heart of the system while the store's open. It's like open heart surgery, right? So it's a balancing act, it's a timing game, but we do our best to not interrupt them any more than we have to, and we have to be open the next day to sell groceries. So you have to have a plan. You have to stick to that plan. And occasionally you have to change that plan, right? But very challenging projects, but well worth it in the end. I think that might be it on our slides.
And reinforcing the NASRC's help to really getting the FRIP program put into place was huge on this. So thank you guys publicly while we're on the phone screen.
Great. Well, thank you for sharing all of this great information. We're going to go take some questions now. So please go ahead and type in any questions you have to the Q&A section. And the first question is for you, Mike. And I'm not sure of this acronym, so we might need some help, but what is the ppm detection level on your ALD?
So it varies by refrigerant, right? It's got to be higher for CO2 than it is for 448 in the world. We put very low limits in from a standpoint of we want to catch a leak as soon as possible. Most of our systems out there at 50 ppm. That's not the case in CO2 because you'll set it off all the time just by people talking in a cooler, right? They put out that much CO2, especially when they're a heavy talker. It really goes up, right? We have seen instances too where sometimes a CO2 leak detector goes off. It's not CO2, it's a piece of dry ice that's come in on a load from external vendor and it sets off our leak detector. So it's a fine line is where you set that, but typical DX systems, we start at 50 ppm.
Okay, great. Another question, this is for you, Mike, and for Jim. What are Walmart's and Whole Foods plans for transcritical CO2 only stores, both for retrofit and new stores? So is that part of your plan at all to remodel and completely get the system to put in a CO2 transcritical only store?
I can probably go first, Jim. So yes, we have plans. Can I say where they're at? I can't right now, unfortunately. The challenge with that, right, is you replace every single piece of equipment in that store. All the cases are removed, all the piping is removed, all the controls are removed, the leak detectors are removed, right? Ice machines, salad bars, blast chillers, you name it, it's replaced 100% wholesale in that facility, which is extremely costly, right? And you're trying to do that in an open store. So we're working through the process of to get one done, but we do have one planned.
Yeah, I'll add to that. I mean, Mike hit the nail on the head. Disruptive, major disruptive. And so back to my 3 principles: minimize store disruption, future ready, and lowest total cost of ownership. Those are really driving it. So from a technology standpoint, we're trying to be non-biased to technology on the front end and look for fit. So our expectation is we will probably see a bit of all of it, but through phased approach. The concept of wholesale replacement is just so massively disruptive, that's difficult. So once you look at phasing, then you get into what are the limitations or criteria for a technology? Are you real estate constrained? Are you structurally constrained? Are you electrically constrained? From a electrical service entrance position to distribution. And so how do the different technologies work into that for a different store? If it's one of our prototypes, it's easier, but we have takeovers, we have older wood frames, you have you're constrained by other retailers on each side of you. So based on that, we assemble what we call the site of that matrix, and it's basically a decision tree that looks at the site, looks at the phasing, and then one technology typically emerges to be a better fit that satisfies those constraints, or best speaks to those constraints, I should say. But at this point, all of the technologies are on the table, and we are implementing all of them in different pilot sites and limited end of life replacements, trying to perfect them all, because again, our expectation is we'll need all arrows in the quiver to be successful.
So, can you speak to kind of the cost premium or percentage increased costs when you compare what you did versus a typical remodel, or even versus what it would take to build a new store?
To me?
Yeah, start with you, but I'm going to ask Mike to answer it too.
Oh, okay. Yeah. I think it's a little early for us to kind of settle in on where we think that premium is, because right now everything's a 1-off, or even a 10 off or a 50 off is really not setting the cost curve when you go to scale. I think once the industry starts to align, we start seeing more and more of these. The manufacturers will partner in different ways, but certainly there's an increase with like the bolt-on skid from a historic like for like replacement. Yes, obviously there's a little bit more, but it was less costly than replacing everything wholesale, to Mike's point earlier. So I can't nail a percent premium at this point. My expectation is as we apply scale, we'll probably start to get pretty competitive.
Great. What about for you, Mike?
So back to what I mentioned earlier, right? We don't close the store during this process, right? So everything is overtime, sometimes double time, depending on the area you're in and contractor you're working with. And it drastically extends your schedule. A brand new store, you can just work, right? Every day you can work, and there's no blackout periods, there's no holidays that mess you up, there's no weekends. We have to work through all that from an operation standpoint. Based on what we have now, I would say we spend double on a project versus a new store.
Wow. And is most of that coming from the labor then?
Yeah, equipment isn't necessarily that much more, right? It is because it's a different technology, but in the grand scheme of things, it's not that much more. It's very much labor intensive to do these projects, and we have to do them in stages in the time you have at night to get the store up and running the next day.
Yeah.
Danny, I think it's important when we're talking about the financial portion of these for remodels. It's not just what the equipment and things cost. The remodel will have a pro forma, and they will have developed a pro forma to say we're remodeling this for an expected bump in sales or something. But there's something that is driving the remodel beyond the equipment. So if it's a remodel where they're just going in and updating certain portions, if we add on that we have to replace cases that were not necessarily part of what the intended remodel was, then it's going to skew your numbers. So, you know, when, as we go through there, the individual parts and pieces of that remodel, if you can pick just the sections that where you can improve the refrigeration side, it will, the numbers will be more meaningful. And all I'm saying is that the cost of the equipment and things needs to fit into whatever the performance is for the for that remodel and what the expectation was for the sales increase and the reason for the remodels.
Got it. So it's more difficult to make a case to do a remodel in a store that might already be in the red.
Well, my point is, so like in some stores where it's mostly medium temp, if you're going in there, if there was a push, if the remodel was for the purpose of improving that area of sales, then the numbers that you're going to put toward that, there will be a payback analysis. You know, so there'd be a way to determine whether it was a good spend, because at the end of the day, it's not how much did it cost. It is, for what we invested, did it give us the return that we were expecting? So, you know, what we don't want to do is incur cost where there's no anticipated benefit beyond just a sustainability piece. In other words, you know, if we have the opportunity to do all low temp and pick that up, and that was part of a break fix or something that was built into it, then you're going to see a return. But it's matching. You have to pick the technology to meet what the performer was and the intent of the remodel was.
Got it. So Mike, you're seeing a return on your $1 million sound wall?
Yeah, we're not getting any more complaints from the neighbors.
Yeah, that's true. Very good point. What about incentives? How are incentives part of the long-term strategy, or just to offset initial costs on the pilots? Hoping that globally prices come down, prices for integrating naturals in existing sites comes down.
So, I mean, I'll try to answer that one the best I can. They are nice to have, right? But they have to be, as I've stated earlier, some of the processes we went through, they are extremely difficult, right? If they're not easy for us, we're not going to use them. So we have to figure out a way to make them easy, or have somebody like an ASRC who makes it easy for us, which is awesome that you guys do that, right? But we have projects and we have timelines, and in this world we live in with supply chain, we can't stop for 6 months to try to get through an incentive process, right? So we will keep moving, and either we have to adjust the project accordingly to deal with the difference in the incentives, or we just have to figure out a way to fund it ourselves, right? We love to have them, but the process has to be much easier than it is today.
Yeah. Great. Well, again, want to thank you all for your time today and for sharing valuable information. And I know there's a few other questions we weren't able to get to, but thank you to those of you on the line today, and we will see you at the next session.